Okay, so good morning, and it's 0900, and we are going to have a lecture on test generation and system testing today. So this part, the test generation, some parts of it we have already covered, but we are, tweaking it and repeating it a little bit. So you remember the requirements pyramid, and I'm going to make it a bit larger. Yeah, like that. And the requirement pyramid starts in the top with the needs and goals of the different stakeholders of the application. So we have something fuzzy or a need, and it's a cloud because it's fuzzy, because it's not well specified, right? But it could be quite simple things also. So perhaps we have a need for an authentication system because we need to differentiate between different users of the system, or we have a need to make money with our web application. So I just want to make sure that I'm streaming sound, so please write in the YouTube comments if you can hear me or not. Okay, the needs can be divided down into features, and these features could, for instance, be an authentication system or a web shop or different things. And then from these features, we can divide them down into use cases. So a single feature could be divided into several use cases. For instance, the authentication system could be divided into registering a new user, logging in with a registered user, and also perhaps logging out. We could also have parts of the authentication system that is maybe giving a programmatic feature, right? So that we can write only users that are logged in can access this part of the application or this part of the web API or something like that. So the use cases and other requirements usually are specified. Perhaps we also specify the features in some kind of user requirements or requirement specification. Part of the use cases could be are scenarios, and a scenario is one path through a use case. And then we have test cases on the bottom. So a single use case can have several scenarios, several paths. So for instance, the logging in use case could have a failed login and a successful login scenario. Then we can have several test cases for each of these scenarios. And a test case is essentially a scenario with test data, with specific test data. So we put values on the different things, right? So for instance, we take Daniel as the username and QWERTY123 as the password. So, and then we also need to have the expected behavior of the system, that we should not be logged in with that username and password, for instance. As part of the specification, we also have other requirements, perhaps not specified as use cases. These could be non-functional requirements or other things, other ways of expressing requirements. And of course, they also map to test cases. We might have test cases that are not directly connected to a requirement, just because we probably, we might choose a specific kind of implementation, and that implementation, that technology, that may require specific test cases. So for instance, perhaps we are using some kind of external API. So we are going to write test cases in order to make sure that that API is up and running and still is communicating in the way that we expect it to be. Okay, so this was just an example of a use case, an alternative scenario. And we have previously talked about path coverage when it comes to code. And now we are generalizing path coverage to also cover scenarios. And we're going to look at the specific use cases. This is the use case UC1 authenticate user. And the main scenario is like this. Starts when a user wants to authenticate. That is the starting point. System asks for username, password, and if the system should save the user credentials. This is step 2. So this is essentially starts when a user wants to authenticate, could be translated in an implementation that we click on a login link, right? When the system asks for a username, password, this is an abstract way of saying perhaps the system either provides a login dialog or something like that, or a login form. So this is step 2, and then step 3, user provides username and password. Now we are in step 3, and then step 4 is system authenticates the user and presents that authentication succeeded. Step 4, and that is the end of the use case, or this main success scenario. Then we have alternate ways through this, and we have 2 different ways. We can start with that one should be able to say that I want to be remembered here, so which means to save the user credentials so that we don't need to input the username and password again. So we have an alternate scenario, which is 3A. User wants the system to keep user credentials for easier login. And then we have system authenticates the user and presents that the authentication succeeded and that the user credentials was saved. So we have a separate 3A, and from that 3A, we can also go to 4A. And so 4A is user could not be authenticated. So from 3 and 3A, we can take paths to both ways of not being authenticated and being authenticated. So if we're not authenticated, system presents an error message, and then we go back to the form, or, the system asks for the user credentials again, and, presents an error message and stuff like that. So if we're talking about path coverage when it comes to code, we've already covered that in a previous lecture, right? But now we might want to consider creating different test cases for different scenarios. And one scenario is a way through this, a path through this. So it could be 1, 2, 3, 4 is one scenario. That is the main success scenario. We have the alternate scenario when 1, 2, 3, A4, where the user gets their credentials saved in the browser, perhaps. Or we could have a third scenario is 1, 2, 3, 4A, 2, 3, 4, where the user first attempts to log in with a faulty credentials and then on the second attempt succeeds. We could have a fifth or a billionth scenario, which is like 1, 2, 3, 4, or 1, 2, 3, 4A, 2, 3, 4A, 2, 3, 4A, 2, 3, 4A, 2, 3, 4, or something like that. We could, end, depending on how this user interface works, we could end the scenario in the middle, right? So perhaps we are ending the scenario in 4A. We're just interested in the error message, but some applications cannot be ended in the middle. So for instance, you could create a console application where this still works. So the starts when the user wants to authenticate. Perhaps this happens when you start the application. So just to start the console application, you need to log in directly. And then system asks for username, password, and if system should save the user credentials, it's just a text. And then you need to write your username. In 3, you need to write your username. And then after that, you need to, as a second thing, write your password. And then we are progressing to 4A and 4 and 4A. Yeah. But this essentially means that we can create as many, if we have a loop in one of these, if we have a loop in one of these, we can create many scenarios. And you perhaps remember loop coverage from the previous lecture, where we went through a loop 0 times, 1 time, or many times. So in order to get loop coverage, we want to go through the loop 0 times, 1 time, or many times. So this could be a guiding way for us to create scenarios that are reasonable, that are, finding bugs but still don't become crazy. So essentially, we can get as many scenarios we want, and from each scenario, we can get as many test cases we want, because we can try to log in with different faulty usernames, different faulty passwords, and maybe you remember that I showed you a couple of different test cases that I wrote with different, an empty password, an empty username, an existing username but an empty password, or an existing username but a faulty password. Perhaps we also have a scenario where we have an existing username and an existing password but from different users, or something like that, just to make sure that we never can authenticate with the wrong credentials. So this scenario, or this use case, is a bit special because it's also a security related thing, right? So we might want to spend extra time here just to make sure that things really work. But this scenario also produces other kinds of test cases. So for instance, if this is a web application, and if the system saves the user credentials in a bad way, that may create a security hole or security problem in our application. So for instance, consider the following scenario, that we're writing the username and password and says, save this so that I don't need to enter this the next time. This behavior is actually, quite outdated now, because most browsers save the credentials for us, right? But maybe I don't even want to see the login form next time, right? So we could have that in the still in one of these. So what if your web application saves the user credentials, clear text, as cookies? This means that in the user browser, there are now cookies with username and password. This is a security threat to the user, because if they lose their computer, or if the user is leaving their computer, someone is going to the browser and looking at the cookies, they can find the username and password. So we might want to have a test case where this is checked, that the username, we scan through all the cookies and make sure that the password is not stored. This could also give for the same thing, but on the server side, or perhaps on the back end side, we might also want to have more test cases connected to one such use case. Like in the database, we don't want to store passwords either, because if our database gets hacked, then the password of our users are leaked out to are leaked out, and then suddenly maybe they are using the same username and password several sites. I don't know if people still do that, but I mean, I'm guessing people still do that. And then suddenly their identity can be stolen just because people now have access to more sites. So we maybe need to check also in the database and see how this is stored. So I get the question, shouldn't the logic have been tested in a unit test? Okay, yeah, sure. So we're gonna look at the testing pyramid, but this is just from generating test cases from one requirement. So some of the things that we are testing now should also be tested when we are writing the code for this. So we can decide where we want to put the test, but all of these tests still need to exist somewhere. And even if I write unit tests for each and every class or each and every method in my system, I can still have bugs that only appear when the system runs together. And in fact, one of the first realizations I had when I started to work with test-driven development was that I had all tests passing, I had 100% coverage, unit test coverage, and my app was not working because I didn't know. I forgot to test it manually also. I forgot to test the system as a system. Okay, so a single use case, we can explode it into scenarios and then explode each scenario into test cases. Yeah, and since I have had an assignment where students were writing authentication systems, I know that all of these test cases are needed. So we've even had bugs from students where passwords were tested in PHP with equals operator. And this equals operator ignored case. So you could have a password with large caps and a password with small caps, and they were actually matching. I've seen the bugs where people could log in just by having a username, or even the thing where people could have a username from one user and a password from another user. I mean, yeah. So I think that this is real. Okay, we've talked about test traceability before, and test traceability we have talked about connecting a specific test case to specific code. So if we had code coverage, I said that with code coverage you have test traceability between code and the test of that code. Now we are interested in knowing if our requirements have tests, and if we got all the functionality that was needed, and we also want to be able to focus on our testing on a specific part, for instance the authentication system. And you've already seen the traceability matrix, so you already know how to do this. You list your requirements and you list test cases, and you can see mapping over those. This is interesting, I think, for change management. So let's imagine that we change a requirement. This is quite frequent. Or I remove a requirement. I also want to know which tests can I remove. So let's imagine that this specific requirement 1, use case scenario 1.1, is removed. We can see that, okay, I can remove this test. I cannot remove this test because it's also used in another. And I cannot remove that one, but I could remove that test. And suddenly I can reduce the test effort, and I can also differentiate between this test failing, because we should not have that functionality anymore, or this test failing because we have a bug. It's also interesting in the way that when we change the software, we want to understand which part of the software have we changed and which tests do we need to regress. So especially if you're running manual test cases, you may want to consider that we are not going to rerun or regress the manual test cases for a part that we have not changed. So let's imagine that we had this authentication system, and we made a change in the authentication system, but not in the rest of the web shop. And the change that we did not concern the web shop itself. It's just registering users or something like that. Now we know that we rerun all the tests for the authentication system, but we ignore regressing the tests for the web application, at least the manual test cases. Okay, so I said in the requirement pyramid we could have other things in our requirement specification, and one of those things could be non-functional requirements. Functional requirements create functions in our program, which means that we are having stuff like we can log in or something like that. Non-functional requirements are spanning perhaps all the requirements. It could be technical requirements, or it could be performance requirements, or it could be many different things. So non-functional requirement testing is quite spanning all of the application also. So let's take a look at non-functional testing at Wikipedia, and you can see that it's just, you know, all of these different titles for different things. So perhaps we go into accessibility testing, and accessibility means that we create a product that is also accessible for people that have perhaps disabilities or things like that. So if we accessibility testing, yeah, we could find different tools for accessibility tools. So this is from another university in Sweden, and I'm just going to go down and show that. Sorry. They have different tools, for instance, for testing color and contrast. This is important for, you know, allowing our customers to, you know, have color disabilities or visual disabilities. So each and every one of these probably requires specific tools and specific ways of testing. Compatibility testing. Are we compatible with a specific browser, for instance? So this means that maybe we want to make sure that our web application works in Edge and also works in Chrome and also works in Firefox. Suddenly, either we have a specific suite of test cases run on each of these as compatibility tests, or we run all our tests on all of them. So if we could, we would run all of them. Okay, compliance testing. Maybe we have some laws and regulations that we need to be compliant with, right? So could we enter this web application? When we first enter this web application, we need to allow the user to not save cookies, stuff like that, right? But if we're handling money or, you know, taxes and stuff like that, it could be that we need to be compliant to the laws and regulations of the countries that we have this, and suddenly this could be quite complex, and we need to create test cases and make sure that we are compliant. Performance. So performance testing, make sure that we can have a responsive system for handling a specific number of requests per second, for instance. We could do load testing, so we make sure that the system is still responsive while it's under a lot of traffic. Scalability testing, perhaps if we have a larger application and it is a scalable application, we need to make sure that we can scale it. So for instance, if we only have 100 users, maybe we only have one web server. If we get 1,000 users, perhaps we are running it on 10 web servers. So in order to make sure that those scripts are working, we need to test this. Localization testing to make sure that, you know, the application is translated correctly. And perhaps we have different, you know, compliance in different countries. So this might be also connected to that. So if we have an international application, and this localization testing, I've done it on my games. So we translated some of our games to several languages like German and Spanish and I think Japanese and stuff like that. And this translating to a language that you don't even know is quite interesting, because I could not test that. I could not, you know, click through the application and test that. So we needed to outsource that to people speaking Japanese. I could test the German and Spanish, but I could not test the Japanese. And that, I think one of the more interesting things that I learned from that was that, okay, language has different lengths in different languages. So, or, you know, words or, you know, sentences have different lengths. So in our games, we needed to adapt so that, you know, a button could be wider when it was having more text into it, stuff like that. Suddenly you could not have 3 buttons in a row because in German, everything becomes super long. And then we have security testing. It could be things like, you know, we have the passwords. We don't say passwords in cookies. We perhaps create a one-time hash and saving those cookies instead. But it could also be stuff like making sure that we don't save any username and passwords or secrets in our Git repository. So there are scanners for Git repositories. Again, all of these different testing types may require specific tools. So essentially, you're gonna look through your requirement specification, and you find all of these, and then you find a suite of tools that is good for you, that is beneficial for you. This could also be penetration testing and stuff like that. And also, you know, reviews of code and stuff like that. So we know that we're using WPA3 or something like that instead of something that is not supposed to be used. Usability testing, accessibility testing. Yeah, sure. Did we have any other cool? So yeah, I think one of the interesting things with recovery testing that I've also encountered was that you know, when you're handling a database, we have backup. We do backups of the database. So we had a system, and they did daily backups on tapes. It was done at that time. Now I think the usual thing is that we have some cloud storage, and that way we can store our data in another country and things like that. But the testing that we did was, how long did it take if one hard drive in our servers broke until we could get the restored thing up and running again. And the interesting thing was that we learned by doing recovery testing, by destroying or pulling out one hard drive and let the system fix itself, that took like 24 hours. And that was super expensive, and then we need to rethink, how can we do this? So I think that is also quite important. Many of these stress testing, volume testing, performance testing things go hand in hand, and it's a field in itself, and I'm not going to cover all of that. But I'm going to show you some tools like the Apache JMeter. So the Apache JMeter, on the course homepage, if you're interested in it, there is a lecture created by a student, I think perhaps 2017 or so it might be a bit old. Apache JMeter is essentially a tool where you can create HTTP requests, and you can program from a user interface how these web requests are going to happen. And the interesting thing with JMeter is that you can set up a number of requests from a single client. So it's acting like a browser, and it's perhaps going through your web application, and it can log in and authenticate itself in your web application. So you can create a user or a user scenario through your web application, and then it can multiply these. So you can have like 10 users using the system, or 100 users using the system. And you can also integrate this with your JUnits, so test suite. So I'm not an expert in this, but this is one of the tools that you could use if you're going to do like performance testing or load testing. So imagine that you're creating one client that is acting like 1,000 clients, and that they are clicking through your web application using this. And then at the same time, you're measuring the response time of these. So you can know that if I have 1,000 users, it may take 2 seconds to load the web page and stuff like that. That could be really useful for several reasons. I mean, we know that people stop using a web application if it's not responsive. And because of that, also Google punishes search results for slow websites. I'm guessing that you knew this already. So this could be one of the tools that you could do. And this could also be a tool that you're using in assignment 2. So perhaps this is the testing that they are missing. So you could try that out. Okay, so we have talked about different test cases. If we could wish for a perfect test suite, I would wish for high coverage. It covers the requirements. It also covers the code. And it finds bugs if there are bugs. So these were the test goal, right? It's fully automated to reduce painful regression testing. So all the checking is done automatically. It should still be easy to change when requirements change. This means that we need traceability, right? We need traceability, but we also need not too many bugs, or not too many test cases, I mean. So we don't want a test case to be thousands of test cases is worse than tens of test cases in that sense, right? Because if I need to change hundreds of test cases, that is painful. So I want to change the test suite easily. This could mean that we want to have a test case to cover a specific thing. So if we change that specific thing and we have traceability to that specific thing, we can change just that test case. And all the rest of the test cases are fine. Okay, it should be quick to develop and can be used during development. So the unit tests are this. They are quick to develop and we can use them during development so that we don't have a big testing effort in the end of development, like the waterfall, but we can have it all the time. It should be minimal, that it gives us enough confidence. So we want it minimal because we want to develop it quickly, but also we want it to be easy to change, but we still want to find the bugs. Okay, and good enough for acceptance testing. So we want to make sure that the different stakeholders still get their goals fulfilled from our testing, their testing goals fulfilled. I'm going to talk more about that today. So should need to be good enough. And this depends on the testing goal. So if we have very high stakes, of course, we need also to have a higher test effort. Generally, we make assumptions to minimize work. So we want these assumptions to be as informed as possible. So one assumption could be that we are just going to test the modules that we just changed. So we only changed the authentication system, so we only test the authentication system again. That is an assumption. The assumption is that we don't have any dependencies or anything else that changed that we don't know about in the rest of the system. See what I mean with an assumption, right? So we are making assumptions, and we want these assumptions to be as informed as possible. This means that we don't want to make stupid assumptions. A stupid assumption could be like, I changed the authentication system, but I understand exactly how this change would change the authentication system. So we don't even need to rerun the tests. I'm confident that my code works. That is a stupid assumption. Why? Because complexity is hard. Devil is in the details, and complexity is hard. And even if you're a really good programmer, you need to test your programs. So you remember black box testing from an earlier lecture, from the first lecture. So black box testing was to examine functionality from the outside without knowing anything of the internals. And tests are generated from a specification. We could have the square root function here. We input 9, and it should output a 3. And we can create these test cases, these black box test cases, just from the outside, from the idea. So one of the techniques, the assumptions that we can use to minimize work that is based on black box testing is equivalence partitioning. Equivalence partitioning means that we divide our input into equivalent disjoint subsets. This is a sentence that I don't know if too many of you understand. Okay, equivalent means the same. Disjoint means that nothing in one is also in any of the others of this subset. So let's say that we have, remember input space was everything. So let's have an example. Maybe that will make it easier. So let's imagine that we only add users of a certain age. So perhaps we let people buy alcohol on the web, and we want to make sure that we only allow adults to buy alcohol. So we input age here. And we want to make sure that it only adds user if they are of 18 or higher. So one way of dividing the input into a valid set or into different subsets is to think about valid input and invalid input. So valid input is valid ages. So an age, valid age, is between 0 and 120. Now I'm assuming things, right? I'm assuming that no one is going to use this web application over the age of 120. That is an assumption itself. Maybe that should be higher, like 140 or something like that. I don't know. How old was the oldest person ever? Google it and write it in the YouTube comments. I think if you're checking certain religious text, you can find an answer that is like 900 years or so. Okay. Okay, invalid ages could be negative ages, ages above 120, or, super high ages, really. All of the invalid, we can put them in one subset, and all of the valid ages in another subset. So, for instance, this could be interesting if we're going to throw an exception on these. So we can divide. But we could also divide the add user int age into 3 different subsets. Like negative ages, like we're going to throw an exception for those. Ages between 0 and 17, which is you're not going to get alcohol. And then 18 and above, you're going to get alcohol, even if you're like 2,000 years old. So we create these different subsets. The equivalent part is like this. We're going to handle the input for this in the exact same way. So yeah, there are slides for this lecture. Sorry for I can put them up in the break. We're going to handle all negative ages the same. We're going to throw an exception for those. So the assumption is that we only need one test case for the negative cases. We might also handle all the valid ages, but below 18 in a specific way. How old do you need to be in Sweden to buy alcohol? 21 still? 20? Okay, 20, okay. So ages between 0 and 19, those are one subset. And then ages above 20 is one subset. They are equivalent, and so we only need one test case for each. That is the assumption that we're saying. Disjoint means that we don't have a number in two different subsets. So the 20 is not both valid and invalid. Make sense? The valid and invalid is one way of dividing things. The the different categories is another way. So let's think about this method. This method has three inputs, A, B, and C. It returns the largest of the three inputs. All inputs must be positive numbers, bigger than 0, and it throws an exception on negative numbers. Think about the different subsets, write in the chat, or raise your hand in the classroom when you have one subset. Yeah?
1, 2, 3.
So 1, 2, 3 is one test case, right? Well, and what is the category or the the equivalent disjoint subset you're thinking about, or the if you put an abstract name of the equivalent disjoint subset for 1, 2, 3? It's valid input, sure. Yeah. So we could have a disjoint subset where we have valid input with one test case, 1, 2, 3. Sure. And another test case that could be in the invalid range.
0, -1, -2.
Sure, 0, -1, -2. So now we have two test cases. We are covering the thing where we have negative numbers and the thing where we have valid input. So we have negative or invalid and valid input. Okay. So what about the largest of the three inputs? If we're thinking about that requirement. So we have 0, 0, 0. So how would that be a test case for the, or what is the, I need to read that, equivalent disjoint subset, an abstract name for that subset that you're thinking about. So how can we divide this into different subsets, really? So 0, 0, 0 could be a test case, but what kind of test case, or what does it belong to? And with abstract, I mean that I want to have like a name. Like we had the invalid and valid was names, right? And then we had perhaps from the age case where we had, can buy alcohol and cannot buy alcohol. We had the invalid, can buy, cannot buy, and then we had can buy alcohol, the three different disjoint subsets. So what are the disjoint subsets here, or what could they be? I mean, there are several. All are equal. So how are that? Yeah, it could be all are equal. Could be a subset where we have like the one that Chris gave, 0, 0, 0, and 1, 1, 1, and 2, 2, 2, and 3, 3, 3, and all these equal are valid. So sure. So what are the complementing other subsets that should complement that?
Negative subset and positive subsets. Maybe
Negative and positives.
maybe one with 2 equals, one disconnected from the equals. So
One with 2 equals. Sure. There are several ways of doing this. The one that I'm searching for is this one. A is highest. Is one subset. So we could have one test case where A is highest. It's like 3, 2, 1, and then one with B is highest, like 1, 3, 2, and then one with C is highest, 1, 2, 3. Make sense? From the throws at the exception on negative numbers, I would have one that is A is a negative number. B, and then one B is a negative number, and then one C is a negative number. But I didn't actually think of the one where everyone was equal also. Makes sense? So we divide into subsets, and then we find a good test case within those, or perhaps a set of test cases within those. Okay. So seldom I'm doing this equivalence partitioning, but I'm never really thinking about it as equivalent partitioning, because most of the cases things are like white box testing, or we get one of these, and suddenly I have a hard time finding the equivalent partitions, even if I should do that. So I think equivalent partitioning might be a bit of a theoretical construct. It's an interesting one still, but this, if we find the equivalent partitions here, it's probably a buffer that contains n and another buffer that does not contain /n. Suddenly, when we have code, then we're more thinking about coverage of the code, I would say, than equivalent partitions. And if you're working with black box testing techniques, but your code looks like this, so you have many if statements and then you have many other if statements, you might want to have, move away from the equivalent partitioning thinking and then more into coverage thinking. Make sense? We could still have, a different test cases. The equivalent partitioning when it comes to white box testing could be like this. I need one test case with one kind of input that goes into this one, and then don't go into any of the other ones. And then I have a second test case that goes into the middle one, and then a third test case that goes into the third one. And then perhaps one that is combining two of these and make sure that the error message is, since it can grow. But usually I'm not really thinking about equivalence partitioning. I have to, okay. But we're going to grow it a little bit because we're having usually also multiple partitions. So let's imagine that we have two different requirements. So you need to be in age 18 to 65 to get a loan from the bank. But we only get a loan if we earn more than 25,000 pounds a year. So you have two different things, age and salary coming in. We identified the input domain. Okay, they are, positive numbers, both of these. I mean, the salary could be a negative number, but that's a lousy job. If you need to pay in order to work. Equivalence partitioning into subset and then combine equivalence classes. So for the age, we have the invalid ages. I guess everything below 18. Like negative numbers, perhaps we're throwing exceptions for those, but we could also have, just handling those. You're not going to get a loan. You're going to return false for a negative number. And then 1 to 17 is going to be also false. And then we have 18 plus is the second one. 18 to 65. So older people than 65 are not going to get loans. And then we have for age also the 66 plus partition. So we have 3 partitions for that. Lower, middle, and then higher. And then salary, we have less than 25,000 and then more than 25,000. We have 2 different. And then we make all the combinations of these. That would mean like this. So you can, since this is just 2 of them, we can graph them. So here we have salary on the x-axis, and here's the line where we have 25. So you're on E1, you're not, or E1, E2, and E3, you're not getting a loan because you are earning too little. And up here, you're going to get a loan because you're earning okay. And then we have age is below 18, where you're not going to get a loan. So this E class here, you're not going to get a loan. And then too old to get a loan is up here. And so the only one, E5, is the one that are getting loans, but the other categories are not going to be getting loans. So E2, for instance, are earning too little, but are of the correct age. Right? So using this kind of partitioning, we can, select the test case in each partition, really. Make sense? Sometimes, if the if statements are like this, there are a lot of if statements. It's hard to know if we really are covering all of these. But the code for this, the code for this particular case is super simple. It's one if statement or two if statement, something like that. Age correct, and then salary above. So maybe that those two if statement does not call for 6 different test cases. Okay, boundary value analysis means that we programmers usually make errors or mistakes on the boundaries between these partitions. So, for instance, it's easy to have less than 18. That is the correct one, right? To identify E1 and E. Less than 18. It's easy to have less than or equal, so to have the wrong comparison operator, or to have a confusion. How old do you need to be in order to buy alcohol in Sweden? I thought it was 21, so I would make a mistake, and a lot of 20 years old are not going to have a happy ending of the weekend because of me, because of my programming error, which is an assumption that I had. So boundary value analysis means that I partition the input domain, multiple partitions perhaps, then identify the boundaries, and then create test cases on the boundaries. So you have one on each side. So for this one, you would have one test case where we are 17 and another where we are 18 to make sure that we have a difference. And then we have one where we are earning 24,999. And then we have the second one where we are having earning 25,000. So, and then the same thing up here, you have one where you are 64 and you could get a loan, but you also have one test case where you are 65 and you don't get a loan, even if you have. So imagine this particular scenario and what test cases I would have. I would have one where we are getting a loan and we're going to get a loan at the main success scenario. I would put that on the border. So I'm 18 and I'm earning 25,000. So I'm exactly, above both of these limits. I would probably want to have one test case up here also within this one, just to make sure that I'm getting a loan when I'm 64 and I'm having 25,000. And then I would have one test case where I have a salary of 25,000, but I'm underage. And then one where I have a salary and I'm over age. Am I missing someone? It's easy to get, I'm just drawing in my head, so it's easy to get. Did I miss any important ones? So I would probably not have a test case down here in E1, where we are both underage and we are, So I would probably reduce that. And I would look at the code and I would do, white box testing, looking at the code, make sure that I have coverage for everything and all the exceptions are thrown for different reasons. Yeah. Okay, so that was the first part of this lecture. So I'm going to put these slides in Slack. So we're going to have a break and we're going to start again at 10 minutes past. Okay, so we're gonna start again. And I want to make sure that share screen. So we're going to talk about system testing. This part of the lecture is extra important for assignment 2. So and I call it planning a testing activity. And I'm going to be quite general in many things and not super specific. And this means that everyone is going to nod and think that, oh, this sounds reasonable, and then you don't think that you've learned anything. So and the actual learning when it comes to all of these things is going to be practice. So A2 is going to be where you're going to apply this and where you're really going to ask the correct questions. So we're going to do a plan for testing for software. And in order to start the plan, in order to have something to plan, we need a strategy. And a strategy is essentially that we need to know what kind of testing goals. I've mentioned it before, testing goals. And when we know the testing goals, we also need to know the means. What kind of resources do we have? And then a strategy is how to reach our testing goals with our means. This is not always possible, but essentially you have some goals and you have some means and you want to reach as far as you can with the means. Could also be that you have really high means. So, okay, what is at stake and what kind of testing goals? So for different applications, we have different stakeholders. These are people that are interested in the application from different. So it could be stakeholders like web shop owners or customers or developers of the project, or like offsite stakeholders like the government and stuff like that. So if we think about the different stakeholders and think about what are they going to gain from our testing, what do they want? And I've just given a couple of examples. So the web shop owners want the full process of shopping tested every day. This is to make sure that customers can fulfill purchases. So this goal is essentially, important for business. Actually, their overall goal is to earn money. But this is, our test that goal put into testing to make sure that we can buy products every day. So developers want to be able to refactor their code without destroying any existing functionality. That could be a goal, right? So they want to feel confident that they don't destroy things. That means that they want to have feedback when they destroy things so that they can fix things. Yeah. So test strategy, the means part. So what means do we have? What do we mean by means? So budget, often we talk about money, right? But budget could also be time. So for instance, we have total time, the deadline when we are, releasing things, or when we are going to release the next version of the thing that we're working on. It could be scheduled time. So for instance, if we have a week and I know that I'm working with this course Monday, Tuesday, and Wednesday, so I'm not going to be able to work with the other course until Thursday. So really this week I have only Thursday to work with the other course. So it could be hours. As educators here at Linnaeus, we count hours for these courses. So I have a certain number of hours to plan my time. That is my means to plan this course or to execute this course. And then we have people, and people that are involved in doing the testing or is needed for the testing. So this is time for testing and people involved in this. Customers, maybe we need access to the customers in order to do certain types of testing. Maybe we need specific testers. Maybe we need experts. Maybe we have developers here. I mean, you yourself, if you're going to be part of the testing that you're planning, need to count in how you need to count you and the other people. Equipment. computers, specific hardware, rooms, cloud computers, stuff like that. If we're developing something where we are, developing a web, I don't know, an app for a mobile phone, maybe you need to have access to different mobile phones in order to do that. So all the things that you need, these are the means. This specifies or limits what we can do. These are our constraints. We cannot, we can ask for more of these, and sometimes we need to do that. Sometimes we find that, okay, we have test goals that are too high, and we cannot achieve these with the means given. Like, I am the only teacher of this course with 95 students. I cannot do everything here. So if I want to, change the assignment or something like that, or, add more lectures, I need to have more means, more people, perhaps. Okay, so if we have goals and we have means, then we can form a strategy. So an example for an application, so since the application is relatively stable and deployed, we want to test the shopping requirements in use case 2 using fully automated system tests on the active system. These should run on a separate server to ensure availability and uptime. So that is our strategy, right? So we know stuff about the system, and we decide that, okay, we can do this. So this fully automated system test. So system test was when we tested the entire application. So all components put together. So in order to test the process of shopping, if that is the use case 2, maybe this is done. So they need to be on a separate server, and we have access to that. Perhaps we have a cloud server, so we start up that cloud server, and then we run the entire system, the entire web shop on that one, and then you can run your manual test cases on that one, or an automated tests on that one. Fully automated system tests. That means that we need to automate shopping of stuff and all the parts of that. We can have different strategies. So if we have limited means like time, and usually we also need to think smarter. So perhaps we divide the testing effort between different iterations. So in this iteration, we focus on the add system API since developers released a new version. Makes sense. We also run regression tests on the login system that was updated. Yeah, makes sense, right? So we can have strategies that, okay, we're not going to test everything because we don't have time to do that. Or our strategy could be that we're gonna focus on automated unit tests and try to automate as much as possible in this project, because we foresee that we're gonna have to release new versions often, and we really want to support the developers. So that is a strategic decision that has a cost, and that has also, we need to have people, that means developers that know how to write unit tests, that have taken this course, perhaps. If we're going to do this fully automated system tests, right, buying stuff in a web shop, we need to have people that know how to do that, that can automate a manual test case. Okay. So let's go down into more planning. So we need to decide what are we going to test, what part, which requirements are we going to test now? So functional or non-functional requirements, what are we going to focus on? And, since we've seen the list of different non-functional requirements, it makes sense to divide this between iterations. So, okay, we're going to develop these things. We're also going to think about the accessibility requirement this iteration, and the next one we're going to focus on security. But we need to focus on security before we release a version publicly. Something like that, right? So you have different strategies. What should be tested? We could have static and dynamic quality. So I previously said that testing is dynamic activity. We run the system and we, stimulate the system and we look at the expected outcome. But some of the non-functional requirements require static testing. So one non-functional requirement should be that we're going to write code of high quality. That could be a non-functional requirement, and we can have a static testing tool in order to do that, or we can have so when I'm talking about testing here, when we're talking about an entire system, we're trying to not be as narrow and as I was on during lecture 1, right, where we try to define what testing is, the testing activity is. Okay, what should be tested? What should we prioritize? Is there any part of the system that is more important? What part did we implement this one? Of course, during implementation, we want to test the part that we implemented. We're also writing test for that one. Perhaps we're writing test for that one before we implement it also, if we're doing test first. And what should be regressed? What did fail last iteration? What code components have been updated? So it makes sense that if we have a failure, that we have released a version, we have a bug, or a part of the system that we understand don't work, of course, we're going to work on that part and we're going to test that part again. We need to understand if we have updated a code component, of course, we're going to regress test that again. And we want to have traceability of test results so that we understand what components should we look into to fix these problems. As important is what not to test. So, I mean, this is just, either you look at the light or you look at the shadow. But sometimes it's easier to say that we're going to test everything except the authentication system. So this is just a way of Okay, the how should we test? So perhaps you've previously seen a testing pyramid. Usually has a little bit fewer levels here. But the further down you're here, the cheaper these tests are. The higher up, the more expensive those tests are. Things within the pyramid is things that we can automate. Doesn't need to be automated. You remember that we can, have manual unit tests. I can, run a small piece of the code manually, like in main, and then look at the results, or you've already done that. So down here in the bottom, we have unit tests. It's wide because we have most of the unit tests. And then we have component tests, and we have fewer of those, but those are checking, a component as a whole. So the authentication system as a whole. And then we have integration tests where we integrate different components together, and we look at the boundaries between these components. So let's make sure that our web API responds correctly according to HTTP standard or something like that. And then they have introduced API tests up here. So and this is also on the boundaries of components or modules of the program. So for instance, this could be if you're providing a web API as your front end for your backend. So as a view as an interface to your backend, right? So you are perhaps testing the entire backend through API tests, through its API. So these are pretty easy to automate using like Postman, for instance. And there are specific API test tools that you can also use in order to. You could, stress test the only the backend through its API, its web API. And then we have a UI test. This is a user interface test. And these normally could be end-to-end tests. That means that I'm testing the entire application from its user interface all the way through all the components of it, down to backend and down to the APIs that it's using. And then on top of that, we have a cloud up here with manual testing. So unit tests are fastest and cheapest. All of the pyramid, we try to automate that. And then manual tests and acceptance tests is most expensive, but they are still important. So I would never, from personal experience, I've learned that even if I try to automate everything, I still have problems like with, I still need to use my application. And I would, if I could decide over my developers, I would say that, okay, we are developing this web app. I want you to personally use it every day. Like if you were beta testers of this, you should use it every day, right? So if you're, I mean, perhaps not personal, but you're, we're trying out the important things. So if I'm a developer of a web store, of course I'm gonna, buy products through this web store. So maybe we have these specific test-specific payment options and stuff like that in order to. Okay. These up here are most expensive, therefore we do them less. These up here are testing a lot of the higher up you come here, the more of the application you test at the same time. So you have a low accuracy. Do you remember accuracy? So if you find or get a failure and you observe the failure, the actual static fault is hard to locate because we have run so much code. Okay, and then more the how. Now, what technology should we use to automate or to run this manually or to do exploratory testing or to run this tester with beta testers or to present this to a customer and let them test it? This depends on our testing goals. I mean, we could have a testing goal that in the beginning of the project, we need to communicate with the customer. They have some idea, they have some goals, right? Or in their head, and we need to extract those goals and understand them, make those into requirements. So one of the easiest way of doing that is to, you sit and listen and you talk to these, perhaps you're writing requirements together, but don't be sure that you've understood what they said. Don't be sure that the customer understands what they want. So one of the most easiest way of doing things is to quickly go home, make a super fast prototype of the thing that they want. Maybe it's just paper prototype, so it's just a couple of papers, or a super easy web application without any backend or something like that, where you just can you click through it and it looks like you're buying stuff. And then you go present that to the customers and you say, is this what you want? In this case, this is the entire prototype as a test in order to see, was this the correct requirements? Are we building this is a validation test, right? So are we building the right product? Okay, so for automation, I want to mention Selenium WebDriver. Selenium WebDriver allows you to write things like this. You have, several different browsers, and Selenium WebDriver allows you to headless, which means that we don't need a screen, right? To run your web application in Chrome, for instance, and in Edge, but you run them as a unit test. So there is not a browser showing up, really. So for instance, you can find a specific button and you click that button. So you can write your system end-to-end tests in Selenium WebDriver in order to test your user interface. You could also mock the backend, for instance, or large part of your web application, and you write front-end unit tests of the actual user interface. So these are run and you can try them out. So you can write automated unit tests that run in Chrome, in Edge, and things like that. Behind here is Postman. So we can decide that in order to automate the testing of our web API, we're going to use Postman and we're going to write test cases in Postman. There are a number of different tools. that I think Cypress is also interesting. So you can see in the animated GIF here that here we are actually animating the browser, I think. And so all the clicks in the browser are actually done. I'm not sure. I think it was done in the either it's recording or it's playing up a test case. I've also seen a previous version of Selenium where you could start up the web application and you had this plugin in your browser and it collected all the clicks you did, and then you marked some text in the browser that this is the text that should show up, and then you save that as a test case. And then when you run it, it brings up a web browser. It clicks moves the mouse pointer and clicks the exact same thing and looks for the text that you so that you could automate UI testing. You can look into Cypress yourself. It's not something that I'm going to do for you. I think Puppeteer is also interesting. Most of the things you can do manually in the browser can be done using Puppeteer. Here are a few examples to get you started. So this one is particularly focused on Chrome, Puppeteer, but you can generate screenshots and PDFs of pages. This could be super interesting for regression testing. So let's imagine that you want to make sure that you have painstakingly written your CSS. And this CSS has been accessibility tested. So we know that it works with disability. It passes the disability tests, right? So we know that the red and green are not used together and stuff like that. And then we want to write a test that makes sure that the appearance of our application has not changed. Makes sense? If the appearance of the application changes, we need to rerun the accessibility tests. So let's imagine that we run the application, we take a screenshot, and the next time we run the application, we're going to compare the new screenshot with the old one. Make sense? So things like that. You can crawl a single-page application and generate pre-rendered content, automate form submission, UI testing, keyboard input, create an automated test environment. And if we look at the script they have below, we can see stuff that they can do, that you can write. So this is like you write these as unit tests, more or less. And then here we can go to a specific web page. We can set the viewport, the screen size. We can type things, we can wait, we can click things, and then we can evaluate if a specific text is there or not. So Puppeteer is interesting for you who want to automate web applications. Okay, now, awesome. Now we have done a lot of testing. We've automated the shit out of it, and we have all our tests. How do we know that we did good or not? How can we judge the test results to be okay or not? And what actions should happen if it's not okay? So this is also part of the test plan. So testing is giving us feedback. What are we going to do with the feedback? How do we judge the feedback to be okay? So for instance, if we have the programming lead wants higher code coverage, we could say that it's good if it's above 85%. If you're working with assignment 1, part 2, you know that it could be, quite painful to create the last 95 to 100% because it's hard to test code probably. So maybe we say that it's good enough if we have 85% code coverage. So the action, if we don't have that, is that we're going to talk to the lead about that. We did see in a previous lecture where I looked at Yoda time that when you are submitting your code, you also need to submit the coverage. So we could have an action that says that, oh, we're not going to merge your code because it doesn't fulfill our coverage requirement. Make sense? So by also putting limits on what we think is okay, and maybe all tests needs to pass in order for us to release a new version. but that is not a clear, to me, that is not a clear thing. Almost every application out there has bugs in it, or non-optimal behavior, and they still release it, right? So we could say that if we find that it doesn't complete all tests, maybe we have some tests that are critical. The authentication system all test cases for that must be, but the web application, it's okay if the performance test of it says that it takes 1 second or above. It's okay, but it's not okay if it takes 5 seconds to load a page. Yes, so we can have different action. If we still have not released it, maybe we have different actions than before, right? So if we implement stuff, but we only reach half of the test cases, maybe we need to focus on that same thing again next iteration. So the test plan is a plan. So it guides our test work effort. This means that in order to have a plan, we need to have someone responsible. If we don't have someone responsible, we say that, okay, we're gonna eat today. Family, we're gonna eat today. First we're gonna cook food, then we're gonna eat food, and then we're gonna do the dishes. And then everyone goes away. Everyone agrees that it's a good plan, right? Because everyone wants to eat and everyone wants a clean kitchen. But if we don't decide on who does it, it's not going to happen. So who implements the test, who runs the test, and who has the vital information in order to do stuff, right? If you assign someone who don't have the things needed in order to do things, so I cannot let my 7-year-old daughter cook the food all alone because I don't want her to burn herself in the oven. But I can do that on my own if we need to. So we can, decide. We also want to find who am I gonna, hand over the results of our testing to. So it could be ourselves, right? So I am the developer. Every time before I do a merge, I'm gonna run the tests, and I am gonna look at the test results myself, and I'm gonna check our criteria for passing or not, if this is a good merge, or we're gonna do that in a team. It could also be that if we're gonna hand over the test results to the customer and say, do you accept this product now? Then that is the one who uses the results. If we are producing results but no one is using them, don't produce the results. We should not do things in vain. Often we create, especially in bureaucracies, we create desk products. Or products that are designed for the round archive, which means the trash bin, right? So and sometimes in my work here, I do stuff or produce products that I don't understand who is going to use this. So I fill in forms and stuff, and and the one that I'm filling in knows all of this information. It feels meaningless, feels pointless. So if you feel that something is pointless, then question it. Who is going to use this result? Why am I doing this? Because you should not do meaningless stuff. Okay, rant over. In the plan, we should also think of risks and assumptions. So what can affect our test process? What do we need in order to do this process? So if we're gonna develop some hardware, we need access to that hardware. If we are gonna set up a test environment, do we have that test environment available? Can we use it? Do we have money for the cloud environment? Access to test specific equipment, access to test personnel, and stuff like that. So if we're gonna do so I'm not sure if I told you the story of my first company. So to together with a student, Ola, he was named. We did form a company when we were still students. And one of the first jobs we had was to update or migrate a system to a new database. So they had an old database that they have outgrown, that they could no longer support, and then they want a more stable database. And so when this was essentially taking all data from one database, putting that into a new database, and then finding all the places where the application connected to the database, and then rerouting those so that they went to the new database, and then also making sure that the system worked afterwards. So we had a process for that. Essentially, we scripted everything, and then we traveled to Stockholm because I was studying here, and where the company was, and they kept all the personnel at work. So we started after their normal closing hours, like 5 or something like that, and then we directly at 5 we started our scripts. First we did a backup, of course, and then we started our script, automatically moving all data from the old database to the new one, trying to start up the system again, and then everyone was still there in order to test the system, because we didn't understand automatic testing at the point, and there was probably not an easy way for us to automatically test the system either. So everyone stayed there, and I think this was around 7 or something like that in the evening, and everyone was getting a bit tired. We had eaten pizza. And finally, the system was up and running again with the new database. And we were like high-fiving, me and Ola. And then people were saying, oh, yeah, this seems to work, but all my work from today was lost. And then we need to search for the error. And I realized that because we used the backup in order to restore data. So we back up data from the old database, and then we restored it into the new database. And I realized I used the wrong file. So it was my fault, and everyone needed to stay 2 more hours. So that was a good thing, but it worked on the second attempt. Yes. Okay. So one of the risks is that we need access to the test personnel. And the mitigation strategy, how do we minimize the risks? So if I need a specific equipment, how can I make sure that I have it on my desk at the time that I'm going to conduct my testing? Plan, and every plan is communication. It's actually mostly guiding people, right? So the text itself or the plan itself is not as important as people understanding what they should do, why they're doing it, feeling motivated to do that, and that they understand what they should do, right? So if I say, okay, you should manually test this app, I should think when I'm writing this plan that, do you know how to do this? Do you have everything that you need? Or do you at least have someone that you can ask? So that so it's a communication, and we want to transfer information. Also part of the plan is the how. In what form should the result be presented? So list of tests that fail or succeed. We want traceability to requirements so that we can understand the effect of this. And also, let's do testing. How do I report the testing done? Who should read that? If no one reads it, then I should not do it. I've already said. Where do I store it? So I mean, today, like in GitLab, you should use tool support for this. And there are plugins for GitLab, for instance, where we can share these test results among people, and we can see exactly break down how much of the work we have done and which which things are working, which are not working, and which tests have been run by other testers, and which should I run. We can see all of that thing. So of course it's going to be. This is the same thing as I've said before. How should we act on the test result, and when is an activity due? So you need time also. This testing should be done at this particular time. So this was very, general. All of the lecture was very general. And I want you to think about these things. So go through these slides when you're working with A2 and make it more specific. So think about these different things. What are the things that you can find? I think that most projects that you find don't have a test plan, because it's probably a thing that we decide in the coffee room. Right? So we're going to do testing of this project, and we're talking about it. We are slacking about it, and we make a lot of the decisions without documenting them. The reason for documenting them is to communicate. But if everyone knows, then we don't need to document them. So in many projects, if they're small enough, we don't need to write things down. For the bigger projects, like the GitLab project itself, this needs to be documented, because a lot of different people are working in the project, and everyone needs to know, and new people are bringing in, and we can't repeat and tell everything to everyone. So if your project is growing and we estimate it to live a long time, it's a good idea to document things, right? But I think that if you document and you think out who should read this and why should they read it, it's going to become a much better thing. And then you're going to be much more motivated also to do that. Okay, so I did see in Slack that I had a couple of questions, so I'm going to take those questions also. Could you explain the things need to hand it in for assignment 2, if there are any? Do we need also to hand in some file containing all our findings, or is the documentation of our findings more of a document we should use as a guide for the presentation? So, okay, in assignment 2, you're going to conduct testing of a system, and you're going to need to document the testing that you've done. And it's super open how you do this. So it could be just slides in a presentation, and then that is it. But maybe you're going to get more slides than you can present in 5 minutes, which is fine, right? You can skip a couple of slides, but you could also have a separate documentation. I would probably have a Google Drive document where you focus. Okay, you go through all the questions that I've had and you answer those questions. And these are supposed to be handed in on, I think, the 4th of January. And I'm going to have a Google form where you hand in a link. Yes, so for higher grade, this is going to matter more than for passing grade. For passing grade, I'm going to, be there during the presentations in January. And I'm going to listen to those, and I'm going to try to ask questions to as many groups as possible. And that is going to be for passing grade, for E grade, to be clear, right? Okay, document your testing performed. Exploratory testing is optional. What kind of structured testing will you do? What did you do and what did you find? Can you explain this part of the A2 more in depth? Okay, so let's imagine that they have automated unit tests. So you run their automated unit tests, and you take a screenshot of the test results, and you present those. Maybe you want to, go through these test results and look through the tests that failed. That could be a really good thing, right? Why are these tests failing? Maybe it's because you have a development version of the program. Maybe it's because they have not yet implemented this thing. Different answers, different projects, right? So this is talking about a lot about the project itself, its strategy for writing tests, how good they are at writing tests and stuff like that, right? So for a passing grade, you are more or less just testing the project as you were a developer of the project, and you document that. The results, what you'd find, okay, these parts are not working right now. Maybe you find a bug database, like an issue database or something like that, with it could be Bugzilla, for instance, where you find that they have 700 bugs for a large project. That is not uncommon, right? So you're trying to learn and you document those things, the answers to the questions. Okay, so in the last session, it seemed like you said for passing grade, you don't need to run our own tests. Yeah. So the difference between passing grade and higher grade is that for higher grade, you also more extensively evaluate their testing effort, and then you extend their testing effort. That means that you add your own tests on top of their tests. Yeah.
We need to present test data in the presentation.
So I get a question, do we need to present the tests in your presentations? You're going to have a really short amount of time. So during the presentation, I would assume the most interesting thing is, what did you really learn here? What is most interesting for other students to learn about your project? What is the testing benefit? So it's not going to be interesting to listen to, all the requirements of the project, all the requirements of Chromium. Well, this is a web browser. And then, your 5 minutes is gone and no one thought that was interesting, maybe. So, so I would say instead, okay, an interesting test find that I found in Chromium is that many of their tests are flaky, which means that they sometimes pass and sometimes don't pass. And the reason for them not to pass could be that, they have done minor changes to the appearance of these of different elements, and a person needs to look at these tests, and this is a big problem when developing web browsers. So yes, I think, is it okay to work on A2 alone? I would say that this should not be the common case, simply because I don't have time to listen to all of you. So then I want specific reasons for that. It could be, that someone has some specific reason for not working with the others. So you can always ask me if that's the case. Okay, I think this is what I have today. So tomorrow I'm gonna answer more questions here in Kalmar right now. Is it in Växjö tomorrow? Let's check it out. Yeah, it's here in Kalmar and online tomorrow, and in Växjö on Wednesday. Okay, thank you very much. See you next week. Presentations are individual, yes, that is correct. Assignment 1 part 2 is due on the examination day, because it's an oral exam with me, so think of it as an oral exam and not really that you need to hand in something. Yes. Okay.